what I like about these problems is that, honestly, if there's ever a time when you're in your own business or working for someone, this is something that you actually will do. The situation we have in the first one, which is about a ski resort, you will want to know these bits of information because it allows you to make business decisions. Like, how many people are coming to skiing and getting full tickets? How many people are coming and getting half tickets? If we raise the price up, did it change? How many people are renting skis? And if people are just how many skis are being rented, then do we need to get more skis, or do we need to replace skis because there's a lot of them that are being used on a daily basis, et cetera, et cetera. So when you get through this problem, I think you'll start seeing how this is something that you actually, if you start getting into jobs like this, you would actually use. Okay? So you're going to get, obviously, a little story problem that comes with it. When you're working with 3 variables, you're going to have 3 things to compare. You want to make sure that you obviously use the same variable for that same situation. That's going to be key. Okay? So we're going to look through here, and it says the operator of a ski resort sells 3 types of tickets. So right there, that's kind of telling me what my variables might be. Okay? So we know we're going to have 3 different types of tickets. I'm just going to make X, Y, and Z, and those are going to be my types of tickets. Okay? My full ticket is $40. My half ticket is $25. And my ski rental is $15. Okay, so again, I'm just kind of writing the information down so that I can just see what I have. At the end of the day, he finds that he has sold a total of 517 tickets, so that's a total of, so I'll do it equals 517. The total number of people skiing during the day was counted at 425, so there's something related to 425. And the total number of people, and he also has a total cash intake of 16,505. So I know I have something that's equals 16,505. Okay? So when I get these problems, I just try to read through it and write down what I know. Okay? And then I look at each thing and I say, okay, what does the 517 represent? That represents total tickets. The 425 represents people skiing, so people. And then the 16,000 represents dollars. Okay? So for each equation, I have to make sure I have like a association with that end result. Okay? So if I look at the total tickets, what might be something, if you know your variables are X, Y, and Z, what might be a way that we can represent X, Y, and Z to equal 517? Yeah, X plus Y plus Z. So X plus Y plus Z. Because they represent all the tickets, and if I take all those tickets of that day and add them together, it equals 517 sold that day. Okay? I'm going to move down to the 16,505. That's a dollar value. So if I look at the dollar value, how might I associate these variables to a dollar amount? How might I associate that? Okay, so how much does X equal? $40. So I could do 40X, yep, plus 25Y, plus 15Z. So each ticket that I have, they're worth a certain value, and all those values together equal to what you made that day. So it's basically all your ticket sales multiplied by how much they're worth. Okay, so that's second equation. So then we get down to the third one. And this third one can be written 2 different ways. So I want to look at the total number of people skiing. Well, of the tickets that I have here, of the variables, is there one that does not represent people? Yeah, the 15, because what is that? That's equipment. Right? This is a person, this is a person. These are ski lifts, meaning people are getting them to go up and ski. The rental equipment is on a person. Right? Right? So not everyone's renting, so you don't want the rentals in there. So you can write this one of 2 ways. You can do just the people, which is X plus Y, that's people, right? Or you could do X plus Y minus Z. In the end, it's the exact same thing. Okay? And I personally am going to stick with x plus y because it's just one less thing I need to worry about. That's just me. Okay? You can do the same thing then, break it into 3, go off, and solve it like you have before. However, if you just use the x plus y, do I have all 3 variables on this one? I don't. So when I do my division, I'm going to separate the two. I'm actually just going to not do this side and just say my end result is x plus y equals 425 because I only have 2 variables there. Okay? Which means on this side, which variable do I want to get rid of? The z. So then I'll stack this one. Okay, and then I want to eliminate z, because that will give me an x and a y, and then I'll have my 2 variables to work my way down. Does that make sense? Okay, so we're not going to continue on with this, but what I'm going to tell you is what the answers are. So when you work through it, see if you can get those answers, okay? So in the end, z is going to be, or x is going to be 300. Y will be 125, and Z will be 92. So when you work to get the Z eliminated and work your way down to pick whichever variable and work your way back up, these are the answers you should get. Okay? Alright, so looking at Monica, she has $1, $5, and $10 bills in her wallet. So therefore my variables are going to be X, Y, and Z. Okay? And I would recommend, as you guys do this, that you do actually mark up what you're reading. That I think it helps. Anyway, she has something that's worth $96, so that's going to equal 96. Okay? So here's something that equals $96. She has had one more dollar bill. She would have just as many 1 bills as 5 and 10 combined. I'm going to go on, and I'll come back to that sentence. She has 23 bills total. Okay, equals 23 bills. All right, whenever you have anything that's just like a total, that's always just going to be your variables added together. Okay, it's like when we had the nickels and dimes and quarters in a bag, and there was 18 in a bag. It's like, how many do you have in that bag, right? So we have x plus y plus z is going to equal the 23. Okay? Then we have where the $96 is a dollar value. So how do I associate money with these variables? Yeah, I have to attach what each one of those variables are worth, right? So my $1 is just 1, so that's just x, plus my $5 is y, so it's 5y, and my z is $10, so it's 10z. Okay, so however many I have, they're worth that amount, so therefore that's my dollar value. Okay? So pretty much you guys got that one pretty easily. Alright, so then we have the next one. And it says if she had 1 more dollar bill. Well, what's 1 more represented as? Plus 1, right? Okay, what's my dollar bill represented as? X. So I have an X plus 1, right? If I had 1 more dollar bill, so I'll say X plus 1. Okay, she would have just as many, so that means equal, 5 and 10 bills combined. Well, what's 5 represented as? Y, and what's 10 represented as? Z. Okay, there's no dollar values associated. They're not saying the value is different. They're just saying how many she has. So you don't do value, so you just have Y plus Z. So that is saying she has 1 more dollar bill. That would equal the total that she has in her pocket of 5s and 10s. Okay, so now to get this so it's more readable, I would bring the 1 to the other side and the y's and the z's to the other. So this becomes x minus y minus z equals -1.
Well, wouldn't there be another x?
Okay, so either way, if you bring the x over or you bring the y and the z over, same equation, okay? So now I have 3 equations and I can divide, right? So the answer on this one, z is 5, x is 11, and y is 7. So you would write this as 11, 7, 5. So when you work this, that's what your goal is to get. Okay? All right, I want you guys to look at number 10 and try to create your 3 equations. So when you solve that, that's what you're going for. Okay? All right, so the process to get down to the answer in regards to stacking the equations and solving down to 2 variables down to 1 variable, hopefully is going to be the review part of this. You guys created your equations, but I want you to be comfortable with creating them, okay? So in regards to your homework, so you need to work these problems, okay? So work 3, well, actually I know it is 3, 3, and 10 on this page. And then on your actual homework assignment, okay, you want to do 25, 29, and 30. Okay, so 25, 29, and 30. So you really just have to work these, and then you have to create them here. Okay? Good? Questions?